Jensen Huang's victory wasn't because he was some kind of prophet who looked into a crystal ball and saw ChatGPT coming.
No.
He didn't see the future. He won because he is a paranoid survivalist who bet his entire company on a technology parallel computing that, well, nobody wanted for 2 decades.
Right.
He built a hammer, the GPU, and then he just waited 20 years for the world to become a nail.
That is a very specific and I'd say pretty aggressive way to look at the man running the most valuable company on the planet, but you're not wrong.
It's the truth. And that's exactly what we're getting into today. We're looking at The Thinking Machine by Stephen Witt. It's a biography of NVIDIA and Jensen, sure, but it's really a history of the last 30 years of silicon.
It is. And our mission for this deep dive is to really understand parallelism, not just as, a ship architecture, but as a high-stakes business philosophy. This is the idea that let NVIDIA conquer what the book calls the $0 billion market.
And the context here is just so important. NVIDIA is a titan now, a multi-trillion-dollar company. Everyone knows the name. But the story Witt tells is about a near misses. The moments the whole thing almost went dark. It's less a victory lap and more a series of near-death experiences.
Exactly. To understand why Jensen Huang runs his company the way he does, with this almost frightening sense of urgency, you have to go back. Way before the leather jacket. You have to go back to his childhood. And honestly, this part of the book really surprised me.
I agree completely. I think there's this public idea of a tech CEO path, you know? Prep school, Ivy League, garage, IPO.
Right.
Witt paints a much, much grittier picture. He profiles Jensen's childhood to explain where that resilience comes from.
Jensen was born in Taiwan, then his family moved to Thailand, and then he and his brother get sent to the U.S. when he's 10.
Right, to live with family.
But there was a huge mix-up. He wasn't enrolled in a regular boarding school. He was sent to a place called the Oneida Baptist Institute in rural Kentucky.
And we need to be really clear about this because the book is so specific. This wasn't some prestigious academy.
Not at all.
It was a reformatory.
It was essentially a place for troubled kids. And so you have this 10-year-old Jensen Huang. The book describes him as the smallest kid there.
And the only Asian student.
The only one. He wasn't there because he was in trouble. It was just a logistical screw-up, but he had to survive it.
And the details are just brutal. He wasn't learning advanced math or anything. His job, his assigned job, was to clean the dormitory toilets.
Wow. And the social situation. He was housed with a 17-year-old roommate.
A roommate who was illiterate.
Completely illiterate, and who, according to the book, was covered in knife wounds from fights.
Just imagine that. You're 10 years old, you're in this strange place cleaning toilets, and your roommate has stab wounds. Most kids would just crumble.
Of course.
But this is where that Jensen personality really starts to emerge. He didn't hide. He didn't call home begging to leave. He made a deal.
It's this fascinating negotiation. It really sets the stage for his whole business career. Jensen taught his roommate how to read.
And in exchange,
The roommate taught Jensen how to bench press.
Witt says Jensen did 100 push-ups every single night before bed.
That's the takeaway, right? That place created what Witt calls an unapologetically carnivorous survival instinct.
Carnivorous. I love that word for it.
He learned how to endure a hostile environment without complaining. And he learned that to survive, you have to make yourself stronger every day. No one was coming to save him.
And that carnivorous instinct is there right away when we jump forward to 1993, San Jose.
Mm-hmm.
And we're not in the classic Silicon Valley garage. We're at a Denny's.
A Denny's with bullet holes in the window, or so the story goes.
Right. And Jensen is there ordering a Superbird sandwich. Apparently, he knew the whole menu because he used to be a dishwasher at a Denny's.
It keeps coming back to that kind of grit, doesn't it?
It does. But the decision they made at that table was the key. In 1993, everyone was obsessed with the CPU, the central processing unit. Intel was king.
Right. You made chips that helped the CPU.
But Jensen and his co-founders bet on 3D graphics.
Which today seems obvious, but back then...
It was seen as a toy. It wasn't a real business. And their first try, the NV1 chip, it wasn't just a stumble.
Oh, it was a total disaster.
Complete and utter failure.
They made a big technical bet. They bet on rendering graphics with something called quadrilaterals curved surfaces. It was elegant, mathematically beautiful.
But then Microsoft entered the chat.
Exactly. They released DirectX, and they standardized the whole industry on triangles.
So just so everyone can follow, why is that a big deal? Why did triangles kill quadrilaterals?
It's all about simple math and standardization. A triangle is the simplest possible shape, 3 points, It's rigid, super fast to calculate.
Okay.
A quadrilateral, especially a curved one, is way more complex. So when Microsoft said the standard for Windows gaming is triangles, that was it. They set the rules.
So NVIDIA basically built a car that runs on diesel, and Microsoft just announced that all gas stations would only sell unleaded from now on.
That's a perfect way to put it. NVIDIA's tech was obsolete overnight. Witt writes they were 30 days from bankruptcy. The company was dead.
And this is the first real bet the company moment. They had zero money to build a physical prototype for their next chip, the RVA-128.
Right, which normally costs millions. You build it, you test it, you fix it.
They didn't have a cash, so they did what they called a suicide run.
A suicide run.
What does that even mean?
It means they used a hardware emulator, basically just software that pretends to be the chip to design the RVA-128. And then they went straight to manufacturing.
Okay, explain the risk there. What could go wrong?
Everything. If you design a chip on a computer and send it to the factory, and you've made one single mistake, one wrong connection out of millions,
The chip comes back as a brick.
a very expensive brick, it just won't work. And you've spent your last dollar making it. If it failed, NVIDIA was gone. Instantly.
It was a true all-or-nothing gamble, and it worked.
Yeah.
The RV-128 saved them. But I think this is what cemented that culture of intellectual honesty.
Yes.
They admitted the NG1 was a mistake. They ditched their beautiful quadrilaterals, and they pivoted on a dime.
And that ability to kill your own favorite ideas is so rare. Most founders would have argued that their tech was superior and just gone down with the ship.
Right.
Jensen just looked at reality, Microsoft won, and he adapted. But the biggest pivot of all, the one that defines our world now, was the bet on parallelism.
Okay, let's unpack this, because parallelism can sound like some dry computer science term.
Yeah.
But the book uses these fantastic analogies to explain it.
They're great.
And before we get there, I just want to welcome everyone to Nonfiction Insights. This is what we do here. We try to strip away the stock prices to look at the engineering decisions that are really driving the headlines.
And in this case, the decision was to build a supercomputer for a customer who didn't even exist yet.
So the traditional chip, the CPU, like an Intel chip, that's a serial processor. Witt compares it to a Wustos kitchen knife.
Right. A really fancy, very sharp knife. It's incredibly precise. It can do anything, slice a tomato, fillet a fish. But the catch is it can only cut one thing at a time.
It's sequential. Step 1, then step 2, then step 3.
That's how computers worked for decades.
And the GPU, the NVIDIA chip.
That is a Cuisinart, a food processor.
Huh. Okay.
It's loud, it's messy, uses a ton of power, but it has thousands of little blades all spinning at once. If you need to chop one carrot perfectly, you use the knife.
But if you need to chop a whole truckload of vegetables instantly,
You use the Cuisinart.
the CPU is a craftsman, the GPU is a factory.
Witt uses another analogy I really like, the dance floor one. A CPU is like one world-class ballet dancer,
Okay.
perfect form, an amazing solo performance. A GPU is 1,000 mediocre dancers.
I like this.
Individually, they're not special at all, but if you can get all of them to move in perfect unison like, glow sticks at a rave, they can create this massive complex image that the single dancer never could.
So Jensen sees this Cuisinart capability and decides to build Seed-A Compute Unified Device Architecture, which is basically a way for scientists to use these video game cards to do really heavy math.
And this was the birth of that $0 billion market. It's so important to get this. He spent billions of the company's money to develop software for scientists. He was putting supercomputer power into cards sold to teenagers to play Call of Duty.
And Wall Street must have loved that.
They disabused it. The stock was flat for a decade. Investors, I think it was Scarborough Value, they actively tried to get Jensen fired.
Why?
They looked at the books and said, you are wasting a fortune on a niche product for academics who have no money.
Why are we making our gaming chips more expensive for features only 1% of people care about?
Exactly. Witt says there were something like 13,000 downloads in the first year. It was a ghost town.
So why did he stick with it? If the market wasn't there, investors are screaming, why keep burning all that cash?
Because he understood the platform trap. If you just make hardware, you're a commodity. Someone can always make a cheaper chip.
Right.
But if you build the software language CUDA that everyone uses to talk to the chip, you own the entire ecosystem. He was building a baseball diamond in a cornfield.
He was convinced that if he built it, they would come.
He was. He believed that if he built the architecture for massive parallel processing, a customer would eventually show up. He just had no idea who it would be.
That is a staggering risk. You're betting the farm on a customer that might literally never be born. It sounds almost reckless.
It is reckless unless you have this fundamental belief in the physics of computing. Jensen was convinced that serial processing, the CPU, was hitting a wall. He just believed the future had to be parallel.
He just had to survive long enough for the world to catch up.
Right, and for a long, long time, it looked like a terrible bet. But then the customer finally arrived, 2012, the big bang of AI.
This is the moment the cornfield finally produces a player.
And the setting is just perfect. It's a student, Alex Krzyzewski, in Toronto, working in his bedroom.
No huge lab, no government funding, just a guy in a bedroom.
And he couldn't afford a supercomputer to train his AI model. He needed massive compute power. So he went out and he bought 2 NVIDIA GeForce GTX 580 cards.
Gamer cards.
Total gamer cards, about $500 each.
And he plugs them in and uses them to train a neural network he called AlexNet.
To recognize images, cats, dogs, cars, you name it. And the result just destroyed the competition. The ImageNet competition was like the Super Bowl of computer vision.
And usually the winner improves accuracy by what, like 1%?
If that. AlexNet improved it by something like 10 or 15% instantly. It just blew everyone away.
And this all comes back to the Cuisinart analogy, right? AI and neural networks are messy. They need tons of math happening all at once.
That's it. The Cuisinart finally found its vegetables. The CPU, that precise knife, was just too slow for AI. But the GPU, which crunches thousands of pixels for a video game, could also crunch thousands of neurons for an AI.
So it turns out that calculating the lighting on a 3D dragon in a video game
is mathematically almost identical to calculating the weights in a neural network. It's all just matrix multiplication.
So the tool he built for gamers was accidentally the perfect tool for AI.
And the reaction from the industry was immediate. Witt describes this scene, it's like an auction for Krzyzewski's team. Google, Microsoft, Baidu.
All bidding millions of dollars for 3 guys in a hotel room.
They weren't bidding for the guys. They were bidding for the realization that deep learning finally worked.
And Jensen sees this. And this is where that survival instinct kicks back in. He sees the result, and he turns the whole company on a dime.
Immediately. He sends an email on a Friday that basically says, "We are an AI company now."
That pivot is just legendary.
But it seems kind of impulsive, though, doesn't it? You have this billion-dollar gaming business. Why risk everything for a science experiment?
Because he remembered the speed of light. He saw that AI was going to move faster than anything Silicon Valley had ever seen. If he hesitated for a second, Intel or Google would catch up.
So he redirects everything.
Everything. He personally hand-delivers the first DGX-1 supercomputer to OpenAI, to Elon Musk and Sam Altman. He realized the hammer he built 20 years ago finally found its nail.
Okay, so this is where I have to play the skeptic a little bit, and Witt does too. Was this just luck?
Right.
Did he just stumble backwards into AI while trying to make video games look prettier?
It's the trillion-dollar question. And if you look at it cynically, you could say yes, he built a graphics chip, and it accidentally turned out to be good for AI.
But that's not the whole story.
It's not. Witt argues, and I think I agree, that it wasn't blind luck. It was preparedness meeting opportunity.
Because he stuck with it.
He suffered through 10 years of a flat stock price. He fought off investors who wanted him out. He kept pouring money into CUM when everyone told him he was crazy.
So if he hadn't done that, when Alex Krzyzewski plugged in those chips in 2012...
they wouldn't have worked, not for AI. The software layer, CUA, was the bridge. Without CUA, they're just gaming cards. With CUA, they're tiny supercomputers.
So the luck was that AI happened to need what he was selling. The genius was having the machine built and ready to go when the need finally arrived.
Precisely. And that stubbornness, it comes from his management style. Witt calls it productive paranoia.
I love that phrase, but man, it sounds exhausting.
It goes back to the Rivio 128 suicide run. His mantra is, we are 30 days from going out of business.
Even today, when there were $3 trillion.
Especially today. He believes the second you get comfortable, you die. The book says he has something like 60 direct reports.
60? That's insane. Management 101 says you should have, what, 6? How can you possibly manage 60 people?
He's not trying to manage them in the traditional sense. He's trying to avoid information filtering. In a normal company, the engineer tells the manager, who tells the director, who tells the VP. By the time the news gets to the CEO, it's all been polished.
It's a game of telephone, and the bad news gets smaller with every step.
Jensen hates that. He wants the raw, unfiltered data from the ground floor, and he holds these things called struggle sessions.
That sounds Intense. What is that?
If someone makes a big mistake, he creates a public forum to break it down. He says it's not to shame them, but to treat every error as a learning opportunity for the whole company.
It's all about that intellectual honesty again.
Is the kid at the reform school.
Mm.
You have to be hyper-aware of everything around you to survive. If you miss one detail, you get hurt.
And that all translates into this operational philosophy he calls the speed of light.
I want to dig into this because usually when a boss says work faster, it just means work more hours.
Right. But this means something very specific. It's an engineering concept. It means calculating the theoretical physical limit for any given task.
Okay, give me an example.
So if you're designing a chip, you don't look at what Intel is doing and say, let's be 10% faster. That's the wrong benchmark.
So what do?
You ask, if electrons travel at speed x and the distance is y, what is the absolute fastest this calculation could happen according to the laws of physics?
So you're not competing against other companies. You're competing against physics itself.
Exactly. And if the theoretical limit is 100 and your process is at 10, the 90-point difference is friction. Bad code, slow meetings, bureaucracy. Your job is to remove the friction.
That's a powerful way to look at it. It takes the ego out of it. It's just math.
Right.
So when you look at the whole picture, from cleaning toilets in Kentucky to the Denny's diner to a $3 trillion valuation, what's the real takeaway here?
I think it's that Jensen Huang isn't a magician. He's a systems engineer. He engineered a company to solve one specific problem, massive parallel computation that didn't really exist as a market when he started.
He built the machine and the world caught up to him.
But the book doesn't end on a purely happy note. Witt brings up some pretty uncomfortable truths. The empire feels a bit fragile.
It does. I mean,
Yeah.
think about the Silicon Shield. Almost all of NVIDIA's most advanced chips are made by one company, TSMC, in Taiwan.
Which is a geopolitical hotspot, to put it very mildly.
If that region destabilizes, the thinking machine just stops thinking.
It does. They design the chips, but they don't actually make them. They are completely dependent on that single supply chain, that 30 days from going out of business thing. It's not just paranoia, it's geopolitical reality.
And there's the other big cost, the energy. We said the Cuisinart was power hungry.
That's the dark secret of parallel computing. It's inefficient by design. You're just throwing thousands of processors at a problem.
And these data centers are now consuming as much power as entire neighborhoods.
Or cities.
So the big provocative thought to leave you with is this. Is the speed of light even sustainable? Computationally, we can do it. We can process the data. But are we about to slam into the physical barrier of the power grid?
That is the question, isn't it? The $0 billion market became a $1 trillion market, but it might hit a wall that no amount of parallel processing can get around thermodynamics.
A fascinating and slightly terrifying reality check. Jensen Huang built the engine, but we still have to figure out how to fuel it. That's a wrap for this deep dive into the thinking machine.
If you want more deconstructions of these complex business stories without the usual hype, make sure you're subscribed to Nonfiction Insights.
Keep thinking. See you next time.